Today I'm sharing my efforts to model parts of an early medieval gospel book using physically based rendering. Here's what I've done so far. The manuscript I'm modeling is the Soissons Gospel Book, one of a group of luxury manuscripts closely associated with Charlemagne's court. I'm curious about the viewing environments and sensory experience of display manuscripts like these. One factor I've focused on is the use of metallic pigments, which are extensively used in the miniatures and for almost all of the text. How legible was that gold? What happened when pages were turned, at different distances or in varied lighting? This is hard to figure out from digital editions. All the silver is tarnished, which means that the part of the page that was originally brightest is now the darkest. Even if the manuscript were in perfect shape, standard digital images and videos give you a really limited ability to experiment with environmental conditions, and if you look at the gospel book in person, they certainly don't let you test things involving open flame. So I turned to physically based rendering, or PBR, using Maya and its built-in Arnold Renderer. PBR is a way of making 3D virtual models where you can specify material details, not just show how things look. The renderer calculates how a particular shape with specified materials will respond to varied arrangements of light and motion. The specifications use measured physical properties of materials and light, so a properly built model reflects what we would actually see in real life under those conditions. I want to stress that my digital modeling is not intended to create simulacra. I'm establishing a range of real possibilities, not proposing a singular reconstructed viewing experience. To create the model, I treat each page as a shallow relief. Vellum is layered with paint, gold, and silver. For each part, I specify the geometry and the material. The geometry for the page is just a plane, but I've told Maya that it is like a piece of fabric, and set features like thickness, stretchiness, and bend resistance. This lets me simulate the way a page flexes as it turns, and even how it acts within a binding. Creating the geometry for the metallic and paint layers is more complicated. I use bitmap masks to create these. The white portion of each mask is where Maya should place that material on the plane. I use a combination of Photoshop and an application called ImageJ to do this segmentation, and it's the most time-consuming part of my process, so I'm working on ways to automate it. Next, I have to create the materials that should be applied in the places on the bitmap. This includes color as well as things like roughness, sheen, and translucence. Here's how that worked for the gold. I began with settings that were based on measured characteristics of gold and other pure metals from material science studies. I also knew the alloy compositions used in the Soissons Gospel Book and several similar manuscripts, so I was able to combine that specific manuscript information with the known specular qualities of the metals used in the alloys. Then I had to figure out how to adjust that basic gold material to show the way it was treated in the Gospel Book. Granular gold, sometimes called shell gold, is made by pounding the gold into a thin sheet, then breaking it into tiny flakes and suspending it in a binder. This gives it a micro-faceted surface that is especially glittery and responsive to light, though not as shiny as leaf gold. To show this, my model for the gold includes a flake map, which allows me to specify the size and density of the gold flakes that make up the pigment. I also had to adjust the surface roughness to indicate how much the surface had been burnished. Figuring out how to represent granular gold led me down some interesting research paths. Microfaceted paint is used for cars and road signs because it reflects light from a variety of angles. This creates a diffusely glowing surface rather than a sharp glare. The use of a similar kind of gold paint on a gospel book might help make it visible at multiple angles, while a manuscript ornamented with smooth leaf gold would have a single ideal angle where it was shiniest. There are a lot of intriguing things to consider here about gospel books displayed on an altar compared to books for individual contemplative use, like books of hours. I've been following similar explorations for silver and paint. These materials are all works in progress, so I appreciate suggestions and research recommendations. One of my major goals was to be able to experiment with light. Right now I'm mostly using high dynamic range images, composite photographs that encode lighting information that Maya can use to create directional light that matches the setting. I've also begun modeling different kinds of light. Here's an example with candlelight. I can set factors like color, temperature, brightness, and the size of the light source with great specificity. This means that given appropriate source information, I could model the difference between an olive oil-fueled lamp and a beeswax candle in color, luminosity, and amount of flicker. To close, I'd love your input. Do you have ideas for modeling materials? How about that process of creating bitmaps better? Have ideas for things I should test about environments or lighting? Please get in touch.